Welcome to one more Flip Classroom math video. 3 tips before you start. First, you can slow down or speed up the playback if that helps you watch the video at your own pace. Second, you could pause the video anytime to jot down notes. Third, you could turn on the captions and watch my words go by on the bottom of your screen. Our topic today is called substituting into formulae. And what that really means is that you're going to get formulae and you're going to have some things that you know, and you're going to be asked to find other things that you don't know. So a formula might have 2 or 3 or 4 variables. For this to work, you have to be given enough information so that there's only one variable left that you don't know, and then you manipulate the formula, the equation, to solve for the thing that you don't know. So another title for this lesson would be Solving Word Problems with Formulae. Okay, so here's our first example. We're going to drop an object, and the distance that it falls is given by this equation. Distance, that's the falling distance, is 1/2 times g times t squared. Now let's define a few things here. G is the force of gravity, 9.8 meters per second squared. If you take a physics class or do this in a physical science class, if you've done anything with physics, you probably already bumped into this number. This is a gravitational constant on the surface of the earth. Everywhere you go, you drop something, its behavior is governed in part by this particular number, acceleration due to gravity. Okay, t is time in seconds. Okay, so first question, which is on the easier side, would be like this. What is the distance after 4 seconds? So I take this, I drop it, maybe I'm standing on a cliff and it falls for 4 seconds. What distance has it fallen? So this is where we get to this word substituting. We're going to substitute what we know into this formula and get the distance. So maybe pause the video and do a plug-in step. You have enough information to plug in and then solve for distance. Okay, I just plugged in what I knew. My half stays as a half. I know my g, it's right there. So I put in 9.8 meters per second squared, and then I put in my 4 seconds. For my t, what did I forget? There you go, it's t squared. Gotta have that. All right, so now pull out your calculator and plug and chug your way through this and tell me what you get. I get 78.4 meters. If you didn't get that, give it another try, see what you can find there. One thing to notice is that I'm going to have seconds squared here because that's squared, and I've got seconds squared here on the bottom of a fraction. So those two units are going to cancel out, leaving me with meters, which is distance, which is what I want. So when you have a complex calculation with lots of units, your units should always cancel out in such a way as to leave you with the correct units for your answer. Notice how this is distance. If I wrote seconds there, something's wrong with that. Okay, let's do a variation on a problem using the same formula. Now we're going to ask you, how long does it take to fall 100 meters? So instead of giving you t and asking you to find d, now we're giving you d and asking you to solve for t. This is definitely a little bit more complicated, but it's certainly within the scope of the skills you have in my class. So first step, do a plug-in step with our formula and see what that looks like. Okay, here we go. Now I know my d, so I put in my 100 for d. I have my 1/2, I have my 9.8 meters per second squared, and now I have my t. I don't know that, so I have my t squared. Now what I want you to do is rearrange, manipulate, and solve that equation for t. All right, those of you who know me know that I like to do all my rearranging first before I get out my calculator and save the calculator step for the end. A lot of you don't work that way. What you're going to do is you're going to crunch your numbers as you go, and that's fine as long as you do a good job of rounding. You're going to get the same exact answer that I get. So let me walk you through that. What I did is I took our equation here and I rearranged it to leave t squared on one side. So all I did is I divided through by 1/2 times 9.8 and put that down here. Notice I'm carrying my units along. I'm just going to explain that. I know, again, most of you guys just ignore the units and just get to your number, but paying attention to units is super good for catching mistakes, and in science, it becomes super important. Okay, so what I did is, here's my fraction that equals t squared. I brought my t over to this side, and I took the square root of both sides to get the square off the t. So now I have just plain old t equals the square root of that fraction. I just dropped it in there. And now let's talk about those units. I've got meters over meters per second squared. So when I crunch the numbers on that fraction, my meters are going to cancel out, and I'm going to have seconds squared inside. I'll take the square root, and that will get rid of the squared on the seconds. So that shows how my units are going to work out right to make the answer seconds. And the number I get here is 4.52 seconds. So to summarize, we were asked, how long does it take to fall 100 meters? The answer is it takes 4.52 seconds. That makes sense. Remember how when we plugged in 4 seconds for here, we got 78 something meters of falling. So it's going to take a little further to fall 100 meters. Let's do one more with a volume surface area calculation around a cylinder. So what I've done is I've started by just reminding you of our formulas. The volume of a cylinder is pi r squared h, and the surface area, we use SA for surface area, is 2 pi r squared plus 2 pi r h. Okay, so in this first one, I've given you r and I've given you h. And those are the only variables in those two formulas, so that lets us calculate all day long. So r is 3, h is 7, find surface area and volume. What I want you to do is go ahead and pause the video and substitute these two values into both those formulas and calculate your surface area and your volume. All right, let's see how you did. So for my surface area, which is what I chose to do first, I did my plug-in step. So I used my formula up here, and I did 2 pi r, which is 3 squared, and then I did a plug-in step for the rest of it, 2 pi r h. Okay, so I just did a plug-in step before I did any calculation. Super important. Show me that on a test or a quiz. This right here, done correctly, is worth points and helps to give you partial credit if you mess up later. Okay, now I'm just doing this math in my head because it's nice and easy. 3 squared is 9 times 2 is 18, so I have 18 pi there. And then 3 times 7 is 21 times 2 is 42 pi there. Add those up, I've got 60 pi. I love doing it this way where I take it as far as I can with mental math without getting out my calculator, and then finally I get out my calculator. The surface area is 60 pi, so I went ahead and did that multiplication. I get 188.5 units squared. Notice I didn't put any units on our diagram or in our numbers here, so I just have to say units squared. So that's my surface area. Volume, much easier calculation, fewer moving parts. Volume is pi r squared h. So I just did pi, here's my r, 3 squared, and then 7 is my h. So r squared is 9 times 7 is 63. So my volume is going to be 63 pi units cubed. I did my math on that. I have 197.9 units cubed. So that's how you do those two with substitution. Now let's run that one the other way. So I've set this problem up a little different. If the height is 8 and the volume is 350 units cubed, find r. So we have constrained that cylinder because it's a fixed volume and a fixed height. So that's going to determine what r has to be to meet those conditions. And guess what? We get to solve for that. So your first step here, do a plug-in step with the volume formula and see what you get. All right, check it out. I plugged in my volume for the volume here. That's 350 pi r squared. We don't know what r is, so that stays as r squared. My h is 8. Now, rearrange this equation to solve for r. Just plain old r. Do that and come back. All right, here's how I did that. To get r alone first, to get the r squared alone, I'm dividing through by 8 pi. So I have 350 over 8 pi equals r squared. To get the squared off the r, I have to take the square root of both sides. I switch the r to this side, so I have r equals square root of 350 over 8 pi. Now I'm going to get out my calculator and find out what r really is. Okay, when I crunch those numbers, I get 3.73 units for r. Now I could set you up to do this one with surface area and give you the surface area and ask you to find r. And that would be a little bit more complex because there's two terms there. but I might save that for a challenge problem on a test. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. You can also watch the video again if you need to deepen your understanding. If you enjoyed the experience, please click like or subscribe.